In this video, we start section 1.2, Basic Functions. To start out functions, we have to first talk about expressions. Expressions in mathematics is nothing more than a list of operations, variables, and numerical values that all list together in some form of a display. So in this case, an expression could be something along the lines of 3x plus 2. You could have another type of expression that provides you with some kind of radical or square root, x plus 4, say minus 17. You could also have an expression that deals with other functions. Log of x plus 2 is another type of function that would be considered an expression. I could add in there plus 7x, which would still cause it to be an expression. Again, keep in mind that we have numerical values, we have variables, and we have operations. Operations such as a radical and a log are very special operations, but they still count as operations. So that defines what an expression is. It is, again, a simple list of operations, numerical values, and variables all combined together. After an expression, we can talk about a relation. Now, a relation is nothing more in mathematics than a very specific comparison between two different variables. So for instance, we might have a relation as y equals 3x. Now this particular relation is completely valid, and we can go ahead and pick an x value. We can create ourselves a table of x's and y's, such that if I pick any x value, I say 0, I can take that value, I can plug it in, and I can get back a y value of also 0. I could plug in positive numbers, say 1, and get back 3. I could plug in a negative 1, negatives, and get a negative 3. This relation here actually has a very special circumstance. It specifically states that for every single x value I plug in, there is going to be one y value returned. Now, a relation that doesn't have that is, say, is y squared equals to 2x. Now at this point, when I try to plug in an x value, you'll notice if I plug in, say, 0, we don't have any issues with 0, because I'm going to get y squared off to the side equals to 2 times 0, which means y squared is equal to 0. But then when I go to solve for y, in the previous videos we said that to get a variable by itself when it was squared, we'd have to square root both sides. So I'll square root the 0, and I'll square root the y squared and get back y. But then every time I take the square root, I must put a plus or a minus. Well, the square root of 0, by definition, is 0, and plus or minus 0 doesn't really have any bounds. So y equals 0 is not an issue. Notice again, when I plug in 0, I get back a singular y value. However, when I try and plug in 1, I'm going to have y squared is equal to 2. And then when I go to take the square root of both sides, I'm going to have y squared inside of a square root equals plus or minus the square root of 2. Therefore, y is equal to plus or minus radical 2. Now this relation, and it is a relation, must be, two different values for y spitting back. So when I ask you what happens when I plug in 1, and you try to tell me, well, I can't tell you exactly what it does, it's going to be either a negative square root of 2 or a positive square root of 2, that tells us that this relation cannot be what we call a function. So, in this particular situation, a relation is nothing more than a comparison between two variables, x and y. Now, the next thing we're going to talk about is a function. A function very specifically says, for every x value, there is only one y value. So y equals 3x is actually going to be a function. This actually can be rewritten as f of x equals to 3x. Now let's be very clear about this f of x thing. This is a notation. It very specifically says that f is a function in terms of the variable x, and that function overall is equal to 3x. Now you'll note here that I could have left it in this form, which this form is the equation form. This form right here is the function form. So now you'll see this notation quite frequently as we go through this course, such that f of x could be maybe h of x. Well, h of x is nothing more than, again, the same notation. It is simply saying I have a function h in respect to the variable x, and it could be just something different. So for instance, 3x squared plus 4x plus 1. I now have a function up here that's a linear 3x, and I have a function down here which is a quadratic. So there are multiple different versions of functions. You may see an equation of two variables here. You may see an equation up here of two variables, such that this one can be a relation. It can also be a function. This one, however, is an equation of two variables that is a relation but cannot be a function. And the reason why it cannot be a function is because if you look at this one more time, every time I plug in a single x value, there are more than one possible y values that spit back. Now, if you're having difficulty with this concept, what you can do, arguably, is try to look at a graph of this function. Well, the graph of this function right here would look something like this. With that graph, you may attempt to apply the vertical line test. And this is something that we've probably seen in previous courses, such that right there and right there, this vertical line fails the vertical line test. Meaning, when I draw a single vertical line somewhere on the graph, it can only cross once or none at all. So over here, this vertical line is fine. Right here, this vertical line is fine because it only touches this point right here. But anywhere on this side, it fails the vertical line test. If a relation or an equation fails the vertical line test, it cannot be a function. So that means that this y equals 3x, which I can draw over here, looks something like this. Every single vertical line that I attempt to draw will cross this linear equation only once at every single vertical line. It will not have an opportunity for that vertical line to cross somewhere else. So this is conceptual knowledge of expressions, relations, functions, and again, the vertical line test, which we have to make sure that we completely understand to ensure that we know how to determine graphically whether or not we have a function, or notationally whether or not we have a function.